This black hole is 1 billion times heavier than our Sun. It existed when the universe was 3% of its current age. That's like a human reaching full adult size in the first month after birth. Not unlikely. Impossible. 13 billion light years away, there's a crime scene. Something grew too fast, too massive, too soon. James Webb photographed the evidence. And now scientists are facing a question that keeps them awake at night. How do you explain something that breaks the laws of physics? You don't. You rewrite the laws. Let me show you exactly why this discovery is shattering everything we thought we knew. Black holes aren't born massive. They start small, hungry, patient. When a giant star dies, its core collapses. Matter crushes into a point smaller than a city. A black hole is born. But that newborn black hole is tiny, maybe 10 times the mass of our Sun, maybe 50. To become a monster, it must feed. Gas, dust, stars, anything that wanders too close. Each meal adds mass, each meal takes time. But here's the catch. Black holes have a speed limit. When matter falls toward a black hole, it doesn't fall quietly. It heats up, it spins, it forms a glowing disk of superheated gas. That disk radiates energy, light, heat, pressure. And that pressure pushes outward. It actually slows down how fast new material can fall in. Picture this. A black hole sitting in an ocean of food, starving, desperate. But every time it tries to eat, its own glow pushes the food away. Scientists call this the Eddington limit. For 50 years, this limit defined how fast black holes could grow. Models were built, simulations were run, timelines were established. The math was clear. In the first 400 million years after the Big Bang, black holes should still be small. 1 million solar masses at most. 10 million if conditions were absolutely perfect. But 1 billion. The math said no. The math said impossible. The math said wait another 500 million years. James Webb didn't wait. It pointed at the edge of observable space. It collected light that had been traveling for 13 billion years. It processed data from the cosmic dawn. And it found monsters. Not one black hole breaking the rules. Several. Across different regions of the early universe, different galaxies, different locations. All of them exceeding 1 billion solar masses. All of them existing before physics says they should. One would be an anomaly, a measurement error, a statistical fluke. But multiple black holes across multiple galaxies. That's not an anomaly. That's a pattern. And patterns don't break rules by accident. Let me put this in perspective. The universe is 13.8 billion years old. 400 million years is nothing, a blink, a heartbeat. Imagine planting a forest yesterday. You return this morning, and you find fully grown oak trees with roots stretching deep into the earth. That's what Webb saw. Fully grown monsters in a newborn universe. Something impossible happened. And now scientists have 3 explanations. Each one is stranger than the last. The first explanation is called super Eddington accretion. Maybe black holes can break the speed limit. Under extreme conditions, matter might fall in through specific channels, streams that avoid the outward radiation pressure, pathways that let the black hole gorge itself. For brief moments, a black hole could eat faster than physics normally allows. Some simulations support this. But sustaining super Eddington feeding for hundreds of millions of years, across multiple black holes in different galaxies, with perfect conditions maintained throughout. Possible, but the odds are not good. The second explanation is more radical. What if these black holes didn't start small? In the early universe, conditions were extreme. Gas clouds were enormous. temperatures were intense, the normal rules of star formation might not have applied. Instead of gas becoming stars that later collapsed into small black holes, some clouds might have skipped the star phase entirely. Direct collapse. No star, no supernova, no gradual growth. Just instant creation of a black hole with 100,000 solar masses from the very beginning. If this happens, the math works better. Starting from 100,000 instead of 10 means the race to 1 billion becomes possible. It's not breaking the speed limit. It's starting closer to the finish line. Scientists call these direct collapse black holes. We've never observed one forming. The conditions required are specific and rare. But Webb's discovery makes this theory much more plausible. The third explanation is the strangest of all. What if these black holes didn't form from gas? What if they didn't form from stars? What if they were already there when the universe began? Primordial black holes. In the first fraction of a second after the Big Bang, the universe was impossibly dense. Matter and energy were compressed beyond imagination. Some regions might have been slightly denser than others. If those regions were dense enough, they would have collapsed under their own gravity before atoms even existed. Black holes born from the Big Bang itself. Not grown, not fed, not evolved. Just there from the very beginning. Primordial black holes would solve the timing problem completely. They wouldn't need 400 million years to grow. They would already be massive when the first stars ignited. Most physicists consider this unlikely. The conditions required are extremely specific. But nobody can rule it out. And Webb's discovery is forcing everyone to reconsider. But this gets even bigger. These ancient black holes aren't sitting quietly in the darkness. They're active. They're feeding right now, glowing with the light of 1 trillion stars, shooting jets of energy across thousands of light years. Webb captured those jets. It measured the radiation pouring from accretion disks. It watched these monsters reshape the space around them. And this matters because black holes aren't just cosmic vacuum cleaners. They're engines. They shape galaxy formation. They heat surrounding gas to millions of degrees. They determine which regions form stars and which regions stay empty. If supermassive black holes existed earlier than we thought, they would have influenced cosmic evolution earlier than we thought. The galaxies we see today, the clusters, the voids, the entire structure of the cosmos, all of it might trace back to black holes that formed in the first few 100 million years. One discovery changes everything downstream. This is why James Webb matters. It's not taking pretty pictures. It's putting our theories on trial. For decades, we built models based on what we could see. Hubble showed us a lot, but the distant universe remained hidden. The cosmic dawn was out of reach. We made assumptions. We filled gaps with mathematics. We convinced ourselves we understood. Webb is testing those assumptions. And the verdict is not good. Our models predicted small black holes in the early universe. Webb found giants. Our theories said impossible. Reality said otherwise. That's not a failure of science. That's science working exactly as it should. Theories exist to be tested. When observations contradict predictions, we don't hide the observations. We update the theories. Somewhere in this mystery is a deeper truth. Maybe black holes can grow faster than we calculated. Maybe they can form directly from collapsing gas clouds without stars. Maybe they existed from the first moment of creation. Or maybe the answer is something nobody has imagined yet. 3 words drive every breakthrough in human knowledge. We don't know. Admitting ignorance is not weakness. It's the beginning of discovery. Every revolution in physics started with an observation that didn't fit. Newton watched an apple fall. Einstein imagined riding a beam of light. And now James Webb is watching black holes that shouldn't exist. 13 billion light-years away, monsters are growing. Too massive for our models. Too ancient for our timelines. Too real to ignore. The universe just handed us a puzzle with no solution. Yet, and that's not a problem. That's an invitation.